Welcome back to the Intro to Linked Data using Python course. Last time we talked about RDF, the Resource Description Framework, introduced it, and this time we will be working on representing terminology using the RDFS and OWL namespaces. Before we do that, something came up that I thought would be an educational opportunity. So this is the last part of the notebook that we did last time, but there's this difference where I'm actually not parsing the friend of a friend vocabulary from that URI, and that's because it is not loading for me. And in fact, if I ping xmlns.com, I don't get a response. It times out. And so this sometimes happens with linked data. Servers aren't always up all the time. So what I've gone ahead and done is I've put that vocabulary in the terse triple language format in the data directory, and I can show that right here of our course repository. And other projects do this as well, so they don't necessarily load vocabularies live. For example, the Apache Jenna project is a well-known triple store for managing RDF data, and they have a copy of this vocabulary, and I've gone ahead and sourced it from there and copied it into our directory so that I can load it directly rather than parsing from that URL, and it works the same way. So I've provided that for you, and that's something to look out for. Ideally, in a linked data world, the HTTP URI names for things resolve. You can actually look up a name, but sometimes there's issues with hosting, and so people will cache or host those vocabularies themselves, but still using the same name. So here I'm not claiming a different namespace. I'm using the same name that other people use, xmlns.com. I'll point you briefly also to this service called prefix.cc, where a lot of people like to register their prefixes. So typically when you have a FOAF colon shorthand in a file, typically people mean this, and so there are various other things like that. Okay. On to representing terminology using RDFS and OWL. So I'm going to start with a helper function here. Given a term and a namespace, I want to know if the stringification of the term of the term starts with that namespace. And so if I go ahead and execute this, so we have our named graph. So we have our RDF lib graph, and we're going to iterate over it. So get the subjects, predicates, and objects, the triples of the graph. And well, if the term is in the Nobel namespace, then I want to go ahead and preprint everything. So everything for which the subject is in this Nobel namespace. So here we go. So we have all of these triples that are defined in this namespace, and there are a lot of things here. Laureate has a label, and this is of type this, and there's just a lot of stuff that's defined. And so I want to break this down a bit and talk a little bit about how you can model these different properties using the OWL namespace, using certain terms. So I'm going to import the OWL namespace, web ontology language, but saying OWL is cuter. And we're going to get what's known as data type properties, and we'll see what that means in a minute. So I'm going to iterate over the triples of my graph, and I'm essentially trying to find subjects where they've been annotated to be of type OWL data type property. And furthermore, that they're in the subjects that are annotated to be data type properties are in the Nobel namespace. And we'll kind of collect those data type properties. So the Nobel namespace defines these things as data type properties: year, motivation, share, and sort order. So let's find out a bit more about those. And we can use some helper methods in RDF So rather than having to filter by triples all the time, we can say, okay, for a given predicate property, or a given property, given thing, in this case it's going to act as the subject, give me all of the predicate objects for that thing. And so for each of our properties, let's let that be the subject of our triples, and let's find out all about what we're saying about those data type properties. And I'm printing an extra line here so we can see each of them. So here's a bit more about what's happening here and what an OWL data type property is. So we have Nobel year, it's a type data type property. Label year, the year a given Nobel Prize was given. The domain is an award, and the range is this XSD integer. And so what domain and range mean in the RDF schema namespace are whenever you have a triple where this property that's annotated with the domain and range, where this property is the predicate in the middle. If you have a triple where you have subject, Nobel year, object, you can infer that the subject of that statement, you can infer the statement that the subject is of type award. You can infer that triple. And you can also infer the triple, whatever the object is of the statement, that identifier, that thing, is of type integer. So whenever you have a statement, something Nobel year something, you know that the subject is an award, and you know that the object is an integer. And so that's what the RDF schema domain and range do. They're these machine actionable properties, whereas something like comment and label, those are annotation properties. They don't really mean anything in terms of inferring additional triples, additional information. They're for humans. We also see that motivation is a data type property. And also, so what we'll see here is what data type property means is that specifically the range is going to be one of these simple literal types. And that has a data type. We learned in the last lesson that these literals can have a data type and also a language if they're a string. So all data type properties are going to have a range that are a data type for a literal value. So motivation is another data type property. I would expect for the motivation, I'd expect the range of that to be a string, because it's kind of a description. Okay, and we see it's liberally specified. It's a plain literal, an RDF plain literal. And the motivation for why the Laureate was given the Nobel Prize, the whole prize. Okay, yeah, we can see that the domain of statements about this has a Nobel motivation of this. The subject of such statements can can be inferred to be of type Nobel Prize. They can also be inferred to be of type Laureate Award. And so what's curious here is how can it be two types? And that's something that may be different that you're used to in other modeling languages. Is this type isn't one-to-one. Something can have multiple types. You might think of it as more like tags or set association. So just like something can be in multiple sets, something can be multiple types, can have multiple types, multiple RDF types. So RDF type, the semantics of that is more about set membership than about, it can only be this type, and thus it cannot be any other type. So you can have multiple RDF type statements about something. Another data type property we have is share. So this is the share of a Nobel Prize given to a laureate, maybe 1, 2, 3, or 4, corresponding to whole prize, half the prize, third of the prize, and a quarter of the prize. So I would expect the range of this data type property to be an integer. Sounds like it can be 1, 2, 3, or 4, and indeed it's integer. And the domain is Laureate Award. So what this is saying is if you ever see a triple X Nobel share 3, you can infer the statement X RDF type Laureate Award. Finally, there's sort order. The sort order of the laureates. I'm not sure what that is, but it has a range of an integer, and it applies to laureate awards. Okay, so we've gone over data type properties. So that's when you have these RDF statements where the object is a literal value that can have a data type. Predicates for which they're involved in those statements. The other type of property for OWL, where you can annotate a property and help define it semantically, is this object property, which is the other case where your statement is all identifiers, so that the object is another identifier. It's an object in the OWL parlance. And so we're doing the same thing as above, but we're filtering for triples where they're in the Nobel namespace, and what are all of the object properties that the Nobel namespace defines. And they sort of identify them with RDF type as an object property. So we see Laureate Award, Nobel Prize, category, laureate, and university. So let's go ahead and do the same thing as before, this time with the object properties, where we print all of the information, all the predicate object information about these object properties. So Laureate Award, a label and a comment, connects each laureate with the part of the Nobel Prize that is the laureate award he or she received. Domain laureate, range laureate award, a subproperty of DBpedia award. So you might have a data set with other awards. And what this means is that laureate award is an object property, so it's something that appears as a predicate. And if you see X Nobel laureate award Y, that statement, you can infer that X is RDF type Nobel laureate, and you can infer that Y in that statement is RDF type laureate award. So you can infer those triples. Nobel Prize is another object property. It's something that will connect a laureate to a Nobel Prize, points to the Nobel Prize received by a laureate. Okay, pretty straightforward. A category, this is the category the Nobel Prize belongs to. And so this is an object property. That's nice. So it sounds like each category has its own URI. So rather than having it be a data type property where the category is the string chemistry or the string physics, it sounds like these categories have URIs. There's like physics as a URI, or the Nobel Prize category physics, and so that's nice. A bit less ambiguous. Laureate is also an object property, which laureates that receive an award. So the domain is laureate award and the range is laureate. So I can imagine if there's a laureate award where there are 3 people who share the Laureate Award, you'll have 3 triples, where you'll have that same Laureate Award, Laureate A, and then 2 other statements where again the subject and object are the same. It's that Laureate Award, the URI for the Laureate Award, Nobel laureate as the predicate, and then that other laureate. And university is another object property. It points to the universities that the laureate was affiliated with during the period. They did their contribution that laid the ground for the award. And the domain is Laureate Award, and the range is, again, something that points to hopefully a more common vocabulary that people know about. Why redefine university? It sounds like bbpa.org did it. So it doesn't have to be redefined under the Nobel namespace, or rather, I guess it does, sort of forked, but it's pointing to something upstream. Another thing that we can point to, other than these predicates, these object properties and data type properties, the predicate part that is defined in Nobel in the Nobel namespace, we also have OWL classes. So things can be types of. So let's see that in the Nobel namespace. So what are all of our triples? Where in the Nobel namespace we have things that are of type OWL class. Nobel Prize, Laureate Award, Laureate category. We've seen these before. So let's go ahead and see these specific definitions using a similar technique as before. So we can see a Nobel Prize is of type OWL class. See also here, talks about the Nobel Prize, it's a subclass of award. A Laureate Award, okay, what is this? Nobel Prize is often divided to several laureates. Laureate Award captures the details of the award given to each laureate, such as the share of the Nobel Prize, motivation, etc. There's also this concept of a laureate, a person or organization who receives one or several Nobel Prizes, also considered a folk agent. And category, okay, the Nobel Prize is given in 6 different categories. And here we have, using more OWL terminology, we're saying that the category has to be one of something. And so that's interesting. What is that all about? I'm going to find these categories by getting the objects of subject category and predicate one of, and just get the next one. And this actually represents the list. A list. So it's an interesting way of doing this. So if we look at category, it's this blank node. And the idea here is that we don't necessarily need a URI for internal data structures. Different people have different practices with it. It seems like the Nobel people have said, we don't necessarily care if you're referring to this part of a list. And so we'll see what that means here. So if we were to take this URI, this object, and print the predicates and objects for it. So this being the subject of something, what do we see? Okay, we see that it has this information where the first of it is Nobel chemistry, and the rest is this. So some of you might recognize this as a linked list structure. So this is a structure that will point to the first element of the list and the rest of the list as an object. And so you can continue this, and it will sort of point to the. So if we were to do this one, we'll get the first being maybe physics and the rest being something else, and eventually the last one doesn't have a rest because there's nothing else to the list. And you can see why, even though these are individually addressable objects, we might not care to have a URI for that points to the third element of the list of Nobel Prize categories. We might not care. And so that's why people might use these so-called blank nodes, where they're not actually labeled with a URI reference. So this is possible in RDF, and so you might see this. I'm going to go ahead and grab OWL one of to find out more about that. And it's a property. It doesn't say whether it's an OWL object property or an OWL data type property. It just says property. You can do that. It's less specific. It happens to be an object property. It's a property that terms the collection of individuals or data values that build an enumeration. So when you have a statement, okay, the domain has to be a class, and we saw up here that, in fact, category is a class. So great, that's consistent with this definition. And the range is this RDF list. And so that's what I mentioned before. A list is this object, this class that will have first and rest properties to delineate the members of a list. So you can see that RDF has a very simple structure. It's all about these triples. So you don't have this this idea of a list with multiple members. You just have, okay, this is a list, and the list, what are some triples I can say about this list? Well, it has a first of this thing, and it has a rest of this other list, and so that's how things build up. You can certainly transform that into something more amenable for analysis, like a data frame or a JSON. But in terms of the absolute base level of how things are represented, it's very simple, and it can be serialized in this very simple format where you just have this universal relation of atomic statements. This is the smallest possible thing you can say, subject, predicate, object, about any kind of data structure. So at this point, I'm going to go ahead and serialize in enterable format what we currently have, and save it to disk. So we didn't actually change anything. So this is the same data set as we started with at the end of the last lesson. We haven't added anything to the graph. Actually, I think we did, didn't we? We added the OWL1 of. So this is our enriched set, and you can use that going forward for the next lessons. So to recap, we've gone over some of the basics of namespaces to represent terminology. So if you have certain classes of things, certain types of things, this would be using OWL class, and you can see the Nobel namespace defines Nobel Prize, Laureate Award, Laureate, and category, and also uses RDFS subclass of to relate it to other things downstream. So what this means is whenever you have a Nobel Prize, you can infer that individual is of type Nobel Prize, but you can also infer that it's of type award. So you can infer that triple. Your reasoner can infer that triple. We also learned about two different types of properties predicates, either the data type property, where the range of a statement is a plain literal type, integer, string, Boolean, anything that is annotated with a data type. But it's something inline that has a string representation. And we also learned about object property, which is everything else, which is where the object is another identifier that can be the subject of other statements. And the Nobel namespace defines a bunch of object properties. So those are the basics of using, and we learned a little bit about some of the things that you can do in the RDFS namespace to accompany these, like these annotation properties of of label and comment. This more semantic one of type and subclass of. Type happens to be in the RDF namespace rather than RDFS. And we also looked at the use of domain and range in the RDFS namespace. So this is a really the basics of defining your terminology using the OWL, the RDF, and the RDFS namespaces. And this is how, as we've seen, the Nobel data set does this to describe the vocabulary of their data and how their data and metadata can be interpreted. Next time we'll be getting into advanced search. So how do you actually search this graph apart from just doing these simple iterations of triple matching? You can do a much more complex search using Sparkle, and that's what we'll be getting to for the next lesson.